In this tutorial, we'll be talking about copying. So we'll be talking about how we can actually copy mutable elements with built-in copy module and the difference between shallow and deep copying. So let's get started. So say for an example, I have a variable here called a and I'll just set it to 1, and if I just want a copy for a, I can say cpy is equal to a. So this will actually not create an original copy, but it will actually create a new variable with the same reference. So since this is an integer and integers are actually immutable, this will not cause any problem. So I can actually modify this. CPE is equal to maybe 10, and then if I just print copy and print the original a, and if I print a and if I just run the program, you can see that the original value has still not been modified, because this is actually an immutable data type. Anyway, this is actually not creating a real copy. So uh, so we are actually able to do that. Okay, so now actually let's see what is the difference between a shallow copy and a deep copy. So a shallow copy is only a one level deep copy and only references of the nested child object. Deep copy is a fully independent copy. I know this is a little bit confusing, but I'll actually make it more clear to you, because when we get into practical, these definitions do not really matter. So now let's actually get into the code. Let's remove this. Now we can see that this was not a problem, but if we actually do something with lists which are actually mutable, so for example I can say my list, and I'll set it to some numbers. I'll say 1 2 3 4 5, and now if I just try to make a copy, I'll say cpy is equal to my list. We are only referencing it. So now if I modify the copy, so if I just try to modify the first element, I'll change this to 1, and now if I print both the copy and the original list, and if we just run the program, we can see both of them have been modified. Okay, we actually have same here, so let's just modify this, and now if we run the program, you can see both of them actually have been modified. So this is not a real copy actually. So in order to make a real copy, you can actually import the copy module. So we can say import copy. So now we can actually copy it. So to copy this, we can actually say cpy. We can actually modify this a little bit. We can actually say copy is equal to copy dot copy, and we'll copy this my list. Now if we just modify it, and even if we just print it, we see that our original list has not been modified. Since this is actually a list, we can modify this, or we can actually create a copy in multiple ways. So for example, I can say cpy, or I can actually say cpy actually is equal to my list dot copy. We can do that. That will actually create a shallow copy, not a deep copy. These are all shallow copies. We'll discuss on deep copies a little bit later. So this will also create a shallow copy. So we can also create another copy, or we can actually create a copy in another method. We can actually say copy is equal to list of my list. So this will also create a shallow copy, or a copy similar to this. So now we'll actually discuss what is the disadvantage of a shallow copy. So this will all create shallow copies. So we'll just remove this. We only need a copy. So we have this copy, and it's a shallow copy. Now let's just modify our list a little bit. So I'll actually add another list: 10, 11, 12, 13, and 14. Or we'll actually pass it up to 13, and we'll wrap this up in an entirely new list actually. And yeah, let's just run this. Okay, we'll have to put a comma here. Okay, so now actually instead of doing this, we'll modify this a little bit more. So we'll say 0 1, this is equal to 10. So we are actually what we are actually doing here is the 0th element of this my list. This my list itself has actually got two lists inside. So we have two lists or two items inside, and those two items are actually individual list elements. So we have a big list, and inside that we have some small lists. So we are actually telling it to access the first list. So in this case, this list will be accessed, and inside that the first element, this is the 0th element and this is the first element. So this 2 will be accessed and that will be modified to 10. So if we run this program, we can see that even though we created a copy, a real copy, it still modified this. It was able to modify this one. So this is where deep copy comes into play. This is where we should be actually using deep copy, because that is what is actually mentioned here. So it is only a one level deep copy. So when we have multiple nested level things, it may not work. So now to actually make a deep copy, we have to actually say, we can just say cpy is equal to copy dot deep copy. I have to say deep copy, and now we'll say my list. Now we don't need this shallow copy because we have the deep copy, which is actually much better and which is actually a real copy. So now even if we modify this, we can see that the original list still remains the same. We have the 2 here, but the copy has actually been modified with 10. So this is the difference between the shallow copy and deep copy. So I now think actually you got some basic idea rather than actually reading this definition. When we actually do it practically, I think have a better idea now. So that's all about shallow copy and deep copy in Python.